Lesson 5. This is on discrete and continuous data. You have to be able to tell whether something is discrete or continuous. If I say the number of dogs in the window, you have to say, oh, that would be discrete or that would be continuous. Here's how you tell. If discrete data has whole numbers only, usually. Continuous data continues, not just a whole number, like a whole number would be 6, it might be 6.5, or it might be 6.5. So it continues. So it can use fractions or decimals. So I said the number of dogs in the window. Does it make sense to have 2.5 dogs? Never have half a dog unless you're a killer. So since the number of dogs in the window, it doesn't make sense to have a half a dog, it would be discrete data. That would be classified as discrete data. Let's do another one. The weight of a bag of apples. Would it make sense, you could have a 5-pound bag of apples, would it make sense to have a 5.5-pound bag of apples? Yes, you can have a half a pound. It's okay to have a half a pound. A baby can weigh 22.5 pounds, so that makes sense. So, what did I say? The weight of a bag of apples, that would be classified as continuous data. Let's see if you're any good. Let me give you one and see if you can get it down. The temperature of the sick kid. What do you think?
Discrete.
Discrete. So is 101. 101 degrees. This fever is 101. Have you ever heard them say that a kid had a fever of 101.5?
Yeah.
No.
Yeah.
You can have a fever of 101.5.
You can?
In fact, what's a normal body temperature?
95.
98.6. Continuous data. Temperature is continuous data. Let me give you another one and see how good you are. The number of boxes in a truck.
Discrete?
Yes, why?
You can't have
half a box.
Exactly. Perfect answer. You can't have half a box. Nobody's going to take a knife and cut a box in half. I mean, not on a normal day. The number of butterflies spotted in a field. Discrete.
Discrete.
You can't have
half a
half a butterfly.
No, that's your killer.
All right, now we're going to learn about scientific notation. This is a regular number standard notation. This is that same number. Could you scoot back up here?
Oh, I can't see you back up there.
Why?
Because it's like,
Too.
it's too up close.
You know, zoom out.
I don't think so.
Yeah, it's
Yeah, I
too
know.
close when you get it.
But I want people to be able to see it.
You can
Or
see
at
it.
least when it's
But you can't run this.
Like, I know, yeah, but it's not.
It's not, I guess it doesn't work on videos.
Anyway, this is called scientific notation. You just take the point, move it 3 places to the right. Okay, I'm going to take that point and move it 3 places to the right, and it turns it into that. 1, 2, 3. But do not leave hookers on your answer. We want to do the same answer, but take off the hookers. Hookers are bad. No hookers. That just looks like a big old mess.
Hookers
So
do look
that's
like
how
a
you
mess.
put your answer.
Oh, Casey. They do.
Now you have to know that this is called the mantissa, and this is called the. Well, that's just the answer. You have to know that that's called the mantissa. Let's see what else you need to know. All right, let's go to the next page. Oh, Pythagorean Theorem. Okay. Pythagorean Theorem. Pythagorean Theorem is what you use when you have a right triangle. A right triangle is when you have a right angle in it. There's the right angle. The right angle will always have a little box in it. How many degrees are in a right angle?
90.
Good. Okay, so let's say that this is 8, and this is, no, let's say that this is 6, and this is 8, and we're wanting this. Now, this has a special name. It's called the, anybody know?
Hypotenuse.
Yes, hypotenuse. And here's how you find the hypotenuse on, hypotenuse. Here's how you find the hypotenuse on a triangle. You see that? That's a little playground. People play in there. You go to the playground, you walk across the street and say, hypotenuse. You go to the playground, walk across the street, say, hypotenuse. So, let's call this A, this B, and this C. What's the hypotenuse on that one?
A.
Go to the playground, walk across the street, and say, hypotenuse. Now, the formula for the Pythagorean Theorem is A squared plus B squared equals C squared. And then, if that's the hypotenuse, these two guys are called the legs. So every right triangle has two legs and a hypotenuse. So this is a leg, and this is a leg, and the C is always the hypotenuse. So we're going to put, instead of A squared, we're going to put in 6 squared. Bring down your plus sign. Instead of B squared, we're going to put 8 squared. Then always bring down your C squared. You always bring down your C squared. What's 6 squared?
12.
No.
No.
Change, what's your name?
36.
36. What's 8 squared?
64.
64. Then you always bring down your C squared. You always bring down your C squared. And then you add the 36 and the 64 together up, and that gives you 100. And you always bring down your C squared. You always bring down your C squared. And then, to get C, you just take the square root of 100. What times 1 will give you 100?
10.
Yes. Chris, sit up, please. Cool. So the hypotenuse on this triangle is 10. And that is how you do the Pythagorean Theorem. And then, now we're going to learn how to identify the length and width of a lid. I'm going to draw a rectangular prism. Sit up straight, face the front. Watch me draw it. I'm going to draw a rectangle. And then I'm going to put a dot in the middle. Put a dotted line up. Go back to the middle. Dotted line to the right. Complete that rectangle with solid, solid. Go back to the dot and go to this corner. And then solid, solid, solid. And let's say that this is 10 feet. Let's say that this is 8 feet. And let's say that this is 9 feet. If I ask you to find the area of the lid of that box, wait, if it was a box, it wouldn't be 10 feet long. Let's make it inches. Okay. That'd be a big box. Big butt box. Okay. So if we want to get the area of just the lid of this box, then I will ask you to outline the lid of the box with a different color up. So we're going to outline the lid. Now, the lid is a what by what? Is it a 10 by 8 or an 8 by 9 or a 9 by 10?
8 by 9.
10.
Well, first you do this. From here to here's how long?
Let's say by 10. 10.
10. From here to here's how long?
8.
8. You would times 10 times 8, and the 9 would not be needed. That's how you do those. And that concludes lesson 5. Cut!